Hello. We're going to be looking at section 5.6, inverse of a square matrix. So in this section, we're going to learn different ways to come up with the inverse of a matrix. And then we're also going to be looking at how that can be applicable in solving a system of linear equations. So first thing is the definition of inverse of a matrix. If you multiply two matrices together, doesn't matter the order in which you do so, and end up with the identity matrix, which is that matrix that has a diagonal of ones from the upper left-hand corner to the lower right-hand corner and zeros everywhere else, then you have two matrices that are inverses of one another. All right, so in example number one, we're going to show that these two matrices A and B are inverses of one another. So we just need to determine this. We have to show that the product of these two matrices is equal to the identity matrix. So let's do that. All right, so what we're going to do now is review multiplication of matrices. All right, so remember what we do here. We start with a 1-1 entry in each matrix and multiply those two entries together. So we'd get 4 times 2. Then we move in both. We go from left to right in our first, and we go from top to bottom in our second. So we go, yoop, and we're going to add then what? 1 times -7. Whatever this is, that's going to be our first new entry. Okay, now we go to our second column. Same first row, now with respect to our second column in our second matrix. So leave it a little bit of room. That's going to be what then? 4 times -1, move, plus 1 times 4. All right, finished with every column in our second matrix, so that means we're finished with the first row. Moving on to the second row. Here we go again. 7 times 2. And then we're going to add to that, what? 2 times -7. Leave a little bit of room. Next is this column, 7 times -1, plus 2 times 4. All right, so what do we end up with? Well, let's see. 8 minus 7, that's 1. -4 plus 4, that's 0. And then 14 plus a -14, that's 0. And then -7 plus 8, that's 1. So guess what? We do get the identity matrix I, which means that matrices A and B are in fact inverses of one another. Fascinating. A couple of notes here. If matrix A does have an inverse, then the matrix A is called non-singular. If it does not have an inverse, then it is called a singular matrix. And you'll see this word actually pop up on your calculator if you are trying to come up with an inverse of a matrix and it's not possible to do so. This word will appear on your calculator screen. Also, understand that only square matrices can possibly have inverses, okay? Non-square matrices are not invertible. Okay, what we're going to do at this point is look at 4 different ways to find the inverse of a 2x2 matrix. So the first thing we're going to look at is example 2a. Okay, so in example 2a, we are told to look at solving this equation, this matrix equation, for matrix X. So this is your setup. We've looked at an example just like this in the previous section, all right? Understand that X, if this equation is true, X must be the same as A inverse. We just talked about that in the previous example. So again, this is just one way to find the inverse of this square matrix A. All right, so again, this is A, this is X. If this is the inverse of matrix A, the product here has to be equal to the identity matrix. All right, so let's go ahead and work this out. Let's multiply here again. So we get A minus 2C. Then we get B minus 2D. And then we get negative A plus 3C. And then we get negative B plus 3D. And this is going to be equal to what? The identity matrix. All right, so at this point, do you remember what to do? We have two matrices set equal to one another. Therefore, corresponding entries must also be equal to one another, which means we have this. A minus 2C equals 1. And negative A plus 3C must be equal to 0. This generates a system of linear equations. This is going to do the same thing. B minus 2D is going to be equal to 0. And then negative B plus 3D is going to be equal to 1. All right, so we have two systems of linear equations. All we have to do now is solve these two systems. I'm going to just use the addition method. So when I do that, adding like columns, I get what? C equals 1, which means if C is 1, A has to be what? 3, okay? In the second system, we are going to add again. B's cancel, and we get what? We get D equals 1, which means B must be equal to what? Well, if D is 1, B has to be 2. Very good. All right, so therefore, the inverse of matrix A, which, remember, is the same as X, all right, which is what we just solved for here, is going to be equal to this. 3, that's your A value, and then 2, that's your B value, and then 1, 1, C and D. So matrix X, same as inverse of matrix A, finished with example 2A.